Hi everyone, welcome back to Workshop, and it's part 2 of the Keithley 225 current source repair. In the last video, which I'll link down below, you would have seen me take the transformer apart to make some repairs, and I basically got power back into the 225 where it was obviously dead before. And on a quick test at the very end of that video, I did report back that it doesn't work. I'm not getting any kind of output worth reporting on this out BNC down here, so there's obviously still something wrong with the 225. So I have been playing a little bit off camera with it in order to try and track down what possibly could be wrong. In the manual there is a calibration guide. Not that I think that it's just out of calibration, I do think there's a fault, and so I was running through one or two of these procedures here, just checking voltages basically at various points in the circuit, like the power supply, the reference voltage, those sorts of things, and I've come across one possible problem as to why I'm getting a problem with the output. But what I will demonstrate first of all is the actual output, and I'll show you what it's doing. Now we're ready for power up. I've got my ammeter hooked up there to the output here, and I've got the decade switches set in the milliamp range here, so I'm looking for 4 milliamps. On the positive side, I'm going to check the positive side there, and I've just set the compliance voltage to a nominal 40 volts. It won't really matter what that's set to because I'm not driving any load apart from directly to the ammeter, so there's basically zero resistance there. So let me just switch on power very quickly and I'll show you what I'm getting on the multimeter. So turn it on, it's in standby at the moment. There's your DP. Let me just hit the standby to on, and we've got 4 milliamps. Now I'm going to turn it off dead quick, because what actually happens, it lasts about 15 seconds and then it starts drifting miles off, and at the same time the transistors on the back of the unit start to warm up. One of them gets actually quite hot, not burning hot but quite hot. Now I did off camera replace those two transistors on the back of the unit. I wasn't convinced that the two that I had replaced it with were perfect for the job. There were a couple of parameters on the transistor spec that I didn't like, so I did actually change them out for a couple of NTE 124s, and that seems to be working better. I'm getting the 4 milliamps as you saw there. So let me reposition the camera, give you a top-down look, and I'll show you what else I've found. So first thing was this 18 ohm resistor that I'd replaced. The original one was burnt out, as you would have seen in the part 1 video. Well, actually I'd picked the wrong value. I'd mistaken that for an 18 ohm resistor when in actual fact it's not. That resistor is meant to be 3.9 ohms. There's this wafer here called the second wafer, and you've got two 3.9s on this side, and you've got a 3.9 and a 27 ohm on the other side. So these two here should have been 3.9. This one's already 3.9, as you can see, so obviously this other one's got to be 3.9. So I went ahead and changed that. I've cobbled together a couple of, well actually I think it's 4 resistors in parallel, just to increase the total wattage of that resistor, because it does actually require a half-watt resistor and I only had quarter watt, so I've made up something. It gives me just under 4 ohms. Perfect, that'll do until I can source the resistor that's fit for purpose there. So as I said earlier, I did actually go through this calibration procedure, not so much to adjust any pots on the board, but basically just to check voltages. It runs through the power supply there, the amplifier 0, the reference circuit, etc., and everything's fine on this top section. The problem comes down to this bias section at the bottom here. Now, with that not being correct, it's no much wonder that my two transistors in the back, one was getting quite a lot warmer than the other one, so it kind of adds up that there's a problem on the bias there. and the test points that you're meant to test across are supposed to give a voltage of between 27 millivolts and 40 millivolts. Well, I was getting 4 volts, way off. So let me just hook that up once again, and let's just double check that before we go down onto the schematic. So here it is, section D, bias, and it's set the range to nanoamps, set the decade dials to 999, set the fine control to 10, set the compliance voltage to 100, set the output to the negative standby, and connect a voltmeter up as shown on figure 16. And here's figure 16, there's the bias, and you're supposed to connect across the shaft of the range select switch, which is your common, as you can see there, and this end of R108. So there we go, I've got my positive lead connected to R108. It's on the underside of that range selection switch. I've got my negative for the meter on the shaft of the range selection switch there. Voltmeter hooked up, and we're all ready for a power up, and I've got all the front panel controls set accordingly. So with the meter set to millivolts, let's power it up, and I should see something in the range of 27 to 40 millivolts. Oh, we've got an overload, so let me just put it down to volts and try that again. And as you can see, minus 4.6 volts. That is miles off, and there's no amount of adjustment on that potentiometer down here which is going to adjust that. And as you can see, adjust R121 for the voltage to be set between 27 and 40 millivolts. And in brackets, this sets the current through transistors Q101 and Q102. So clearly there's still a problem with the unit. So let's go down onto the schematic and take a look at that section of the circuit. And here's R121 here, a 1K, it's a bias adjustment pot. And as you can see, you've got a plus 12 volt rail coming along here, and you've got a series resistor, 3 diodes. So by adjusting this potentiometer here, you're then biasing along here and down onto Q102 and Q101 exactly as it says in the procedure. So I've been checking some of the components in and around this bias adjust pot here, and the diodes are all okay, the pot's okay. I'm getting my plus 12 up here, but this R120 10K resistor, it's measuring about 11.5 in circuit. So what it's measuring out of circuit, I don't know. So I'm going to remove it from the board and change it anyway. And there it is, removed. Let me just double check the resistance of it. Yep, 11.7K. Let's change that. Okay, so what I have been doing is I've been pulling a couple of the transistors one after another around here just to make sure that they're okay. So obviously Q101's okay, that's one of the transistors on the back of the unit, and this is actually the one that's getting quite hot. So I thought I would double check, make sure Q102 is okay, because if that was driving on or hard all the time, that would obviously cause an issue with the bias adjust and also driving Q101. So I've pulled Q102, let's go onto the tester and see what it's like. Now I have managed to pick up this rather nifty transistor component tester, and it's the Peak Electronic Design DCA 75 Pro. This in conjunction with an app that runs on Windows, brilliant for just quick testing of the likes of transistors. You've got 3 leads here, you can just hook them up any way you want and it will report on the LCD here, but also the app on the PC, which lets you run through a lot more tests and gives you a lot more information about the state of your transistor you're trying to test. So I've pulled Q103 from the board, so let's plug it in and see what happens. So I'll just put the leads on any way I like. making sure they're not shorted out to each other. There we go. And here's the app ready for a test, so I'll just hit the test button. And look at that, no component detected. Now I'll go and plug in a good transistor, one that I know is working, and let's show you what this Peak DCA Pro actually looks like when it does detect a good transistor. Okay, new random transistors in place, let's hit the button. And there it goes, it's telling you it's a PNP transistor, and you've got the base emitter collector on the green, red and blue leads, and you can see it's got an HFE of 56, a collector current of 5 milliamps, and a host of other information there. But you can also go and plot some graphs. So I was testing Q103 there. Q102 I'd already tested. I thought that might be the one that was faulty, but that one's okay. So it's Q103 here, a small NPN transistor, and that one looks to be gone. Well, so far Q103's gone. I've replaced that with a 2N3904. Q106 is gone. I've replaced that with a 2N3906. Q102 is okay, and I've just pulled Q104, which I've got in my hand here, and if you look closely you can see little burn marks on the underside of that leg there, and putting it in the tester it thinks it's just two diode junctions, which is not much surprising given that one of these legs is blown. So yep, I'm going to have to find a replacement for this one here. So yes, I did end up changing a number of transistors. This one here, that one there, and this one I just done, Q104, and I've changed it out for a 2N5416 PNP transistor there, so hopefully that will do the job. So I've just set it up again to measure that bias voltage at the test point, and we're looking between 27 millivolts and 40 millivolts. Hopefully, rather than that 4 volts or whatever it was I was getting. So here we are, all set up again, and I'll just power up, and if I need to I can adjust this pot here. So let's see what we get. Wow, 31.5 millivolts. Yep, that's smack in the middle of where I need to be, although it is starting to drift there. So let's switch off. And my transistors are stone cold now. Excellent. So let's go and see if it is actually working now. Let me just disconnect the test leads. Okay, and here we go, ready for a power up. Let me just reset it back away from that test settings. We'll go for 5 milliamps I think this time. Let's see what we get. And I'll leave the compliance voltage full up, filter off, and let's hook up the, oh it's already hooked up, test lead, and let's go. Okay, we've got 5 milliamps. Ah yes, okay. For some reason it was at 5 milliamps when it was in standby on first power up. That's a little bit weird. Yep, 5 milliamps there. Let me just switch it off and check for temperatures. And the transistors at the back are nice and stone cold, looking good. Okay, we've got 0 milliamps this time, 5 milliamps. Yeah, it looks like it needs calibrated, but that's no surprise. I haven't selected any transistors and matched them in any way, shape or form. So let's try the negative. Yes, minus 5 milliamps. And let's try this one here. So now we've got a different decimal point. 50 milliamps. Yes, 50.0. Yep, slightly out. And on the negative side, minus 50, looking good. Okay, let's see if we can get something out of the microamps. So this time we'll go to 123 microamps. Let's see what that does for us. Well, yes. Run out of resolution on the meter, but looking good. And on the negative direction, yep. And let's wind that right up to 999. Yes, 1 milliamp, again reading slightly over. Weird thing is, it does take its time to drop back down to zero. I've put it on to standby and we've still got something on the output there. But I've never used one of these units before, so I don't really know. Yeah, something not quite right there, I think. Let me just check temperatures again. Yep. Stone cold. I won't bother checking nanoamps, not with this meter. So let's go back to milliamps and let's just set it down to 0 and see what we get. That's looking good. And 1. Yep. But wait a minute, I forgot I haven't set the fine adjust back to 0. Yeah, that's made a little bit of a difference. So let's call that an inaccurate meter. So let's put it to 50 again. Yes, that's looking a lot better. Yes. I think before I recalibrate it anyway, I would run it for a good few hours, let all the components that have changed out stabilise, and I do actually have a resistor on that range select switch still to change out. I'll need to get the proper size resistor there, that 3.9 ohm resistor, before I do any calibration. But I think it's working. And for some reason it's going back to 0 now when I go hit it back to standby. Let's try some other settings. 20. Back to standby. Still got a problem going back to standby for some reason. Not sure what's causing that. I think we've got a dirty contact on the switch here. Yes, I think that's what it is. I'll need to clean that switch. So here's the standby switch here, and you can see it's got open contact, so it's not much wonder it's a little bit dirty when it's exposed like this. So I'll get my contact cleaner out and we'll just go over that and clean up those contacts. Yep, and that's the switch fixed. A little bit of deoxit on there, and now we've got a nice reliable return to 0 milliamps. Perfect. Every time. So there we go, appears to be working perfectly now. I've just got to clean up the front panel. I'll do that at a later date. It's a bit grimy on the front, etc. And it looks like we've got another precision instrument for the workshop. I'm sure this will come in handy for checking calibration and etc. of some of my other precision instruments. And yeah, I really enjoyed this one. We had some knackered resistors, blown transistors, the transformer needed ripped apart, and really enjoyed the repair. So if you want to see more of these types of repair videos, make sure you subscribe. Thanks for watching.